I've been working on myself. I really try my best to change, but sometimes in a love fade, right? Maybe we should stay in bed, pretend that everything's the same, just a little play pretend, right? But baby, we're changing.
Hey robot makers, hope you're having a good day so far. So do you want to learn how to convert old 1980s basic games into MicroPython and run them on a Raspberry Pi Pico? Then this is the show for you. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get to the keynote slides and have a look what today's show is all about. Here we go. So yes, this is all about retro coding and trying to convert some of these old games from BASIC into MicroPython. And I've got this book on my desk actually at the moment. We'll have a look at it in depth in a minute. I'll just hold it up here. And this is our original book from the 1980s. We bought this one very long time ago, probably when it first came out, from a local bookshop called W.H. Smith's, which is very popular in the UK. You'll find it at all the airports and transport hubs. So let's have a see what we'll cover in today's show then. So yes, we're going to have a look at some basic code. We're going to look at techniques to convert this. You could just stick all this in ChatGPT, but where's the fun in that? We want to learn some techniques, better programming techniques, and we can also see how things have improved since the 1980s from a programming perspective, particularly for beginners, students, and so on. So we're going to improve a game that we're going to type out from the book today, and we're going to run it on a Raspberry Pi Pico using MicroPython, because you get that same kind of 1980s vibe from this because we're running it from the command line from the REPL. So this book I've got here then, this Rainbow Book of Basic Programs, it's actually designed for many different platforms that are available in the 1980s. So the Sinclair ZX Spectrum, I think it might be called the Timex Spectrum over in the States. We had the BBC. There's a few variants of the BBC computer, the Master B, and so on. We have the Electron as well, the Dragon, the VIC-20. So yeah, these are quite probably UK-centric computers because this book was published in the UK. But yeah, most of these computers, if not all of them, ran some variant of BASIC, which is the Beginner's All-Purpose Symbolic Instruction Code. I'm sure that's one of these backronyms. I'm sure they came up with the word BASIC because it was a basic language. And it was created in the 1960s, BASIC, by John Kemeny and Thomas E. Kurtz at Dartmouth College. And the idea behind BASIC was to provide a simple way for students to write computer programs and understand the basic principles of programming. And what I find interesting is how things have changed in those 30 or 40 years. 40 years, is it that old, since we had these computers in the 1980s, this sort of explosion of personal micros. So one of the things I notice when I look through these basic code things, if I just hold up one here, for example, this is games BBC computers play. You can see the code just there on the screen. It's all in caps, so there's no lowercase and uppercase. That's something that came along later on with the likes of mainframe C and languages like that. And a lot of the times that you wouldn't actually have to type in the whole word, so the word print, you wouldn't type in PRINT, you'd just press the P key and it would have the word print on the actual key itself, and the whole word would just appear. So it's a different style of programming than we're used to now. The other thing as well is that line numbers are really important in basic programming because that's how we actually address the individual lines of code. We can say go to a particular line of code and the code would jump to that section, that code block. So there was no functions or anything. It was all just one big listing of code, and the code blocks were controlled using these go to and go sub. Go sub is go to a subroutine, which is like a block of code that performs some specific task, very similar to how we'd have like a function nowadays. And variables tended to be single letters. So if you're writing a program and you can only have a single letter for the variables, that makes them quite difficult to read. They don't read very naturally. One of the things that's happened over the course of those 40 years is that we have variable names that are a lot easier to read now. They tend to be the word representing what they are rather than just like an individual letter. And that was really just down to how much space was available on the micros of the day, so they didn't have lots of RAM to be able to store luxurious names of variables. They just had these letters. Also meant you could only have like 26 variables probably. So what we're going to do to translate this basic program from BASIC into Python and MicroPython, so we can run it on this Raspberry Pi Pico I've got on my desk. We're going to look at anywhere in the code where it says go sub. We're going to change those into functions. Anywhere where we have variables that have a single letter, we're going to change them into a meaningful name. So instead of Z, it'll be zombies, for example. And we're going to change anywhere where they say dim. You can see on the screen there, line 170 and 180 have got dim. Their dimensions, they are arrays in effect, arrays or lists. So we can very easily convert those. And comments, we're going to add some comments to our code. That seems to be something that was missing from a lot of these languages back then as well. They would manually put the comments in next to the code listing. And we're going to run this, like I said, on MicroPython on a Raspberry Pi Pico as well. So just give a shout out to our sponsor, so PCBWay. I'm going to do two things. I'm just going to go over to this web browser, and I'm just going to load up PCBWay.com. So a while back I designed my own PCB, which is a Bluetooth remote control for a robot, and you can see that it's got a Raspberry Pi Pico, and I got 5 of these in one pack. So you can see there they have, for $5 you can get 10 PCBs for $5, which is insanely cheap. It depends on what kind of things you have. So this one was a very simple 2-layer board with through the hole components, and it simply just got 8 clicky push buttons, little battery connector, and then the Pico just goes into the little header pins there. So I simply just designed this in Fusion 360. There's actually a show if you want to watch that, if you just search in my channel. And then I went over to PCB Way, and I went into this screen that you can see now. So I went into the, I think it was instant quote. You can then say what size of board you want to use. So what is the actual size of the PCB you want to end up with. And that will define one element of the price. You can say how many different layers you want to have it on, so you can have up to 14 layers, which is crazy. And then the thickness of the board as well. So I just chose some of the default ones, and they've got this option here, get $5 free prototyping order. So if you're ordering really small numbers, they're really good with that. It's very easy to order basically prototypes of your thing, and then when you come to order multiple copies of this, you've got everything good to go, and you know everything fits and works the way you want. They can also assemble the PCB for you as well if you want, from $30. That's for 100 components. Sorry, they've got hundreds of components from different vendors as well to be able to put in there. You can get rigid, you can get flex, rigid flex PCBs, and they also do CNC machining as well. So if you want some kind of nice aluminium part creating or a 3D printed part, they will also do that too. So you can have the full experience of having something manufactured. And when I got these, I think it was less than 2 weeks from me actually pressing the button to upload this to actually receiving it in the post. And the fit and finish of these is absolutely amazing. So really, really smooth, no sharp edges, everything was precisely machined, no errors whatsoever in the manufacturing process. So can't wait to start working on another PCB very soon once I've got open source out the way, and yeah, I'll be definitely returning back to PCB Way to place a few orders myself. So check them out, and thank you again for sponsoring today's show. Okay, so let's get back over to zombies. So we're going to escape the swamp and avoid some zombies today. Let's have a look at this in a bit more detail. So this book that I've got here, I've got a little bookmark in so I can just find it very easily. There we go. So this page that you can see on the screen here is from this book. And we're going to look through the basic code. It's just 49 lines of code. They have got some subroutines. We're not really going to look at those, to be honest. I could just show you where they are in the book so you can understand what they do. And we're going to explain what the main blocks of code do. So they've got a nice section on the screen here. If you look at this line notes, I've got this in Visual Studio in a second, so we can have a look at this in a bit more detail. But they've essentially grouped together blocks of code, and they've explained what each of those do, because it isn't very easy to read. That's one of the first things when I looked at this, and I'm quite familiar with programming. I look at this and I think, ugh, that's a bit horrible. That's a bit complicated to read. So then, yeah, the book has also got instructions on how to play the game, how to win the game, how to lose the game. So this we'll have a look through this introduction and some hints that they've got too. But that's the entirety of the game. This is one of the things I love from the 1980s. You could buy a magazine, things like Computing Weekly, or there was a Crash magazine for the Spectrum. I remember we used to get that one quite often, and they would often have these code listings, and you'd have to sit there, type away, and hope there's no kind of mistakes in it. You'd certainly learn how to debug code if you did come across any of these kind of issues. And yeah, then you could run the game and the game would play. A lot of these games tended to be number guessing games and very basic games. They didn't tend to have graphics in them, simply because it's quite hard to do graphics programming on these machines. And if you do, they just tend to be loads of like statements to push pixels around, and it's not very interesting if you just want to quickly, you know, have a bit of fun for 15 minutes typing out a game like this. It'd be a lot more laborious to do that. So how we actually control this game then. So in the book, they talk about pressing the number keys 1 to 9, and they've got them in a kind of grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9 in that kind of arrangement. We're going to do it slightly different. We're going to use QWE, ASD and ZXC on the QWERTY keyboard. So we've got like a little control set of keys there, almost like a joystick. And you can see on the screen there, this is kind of what it's going to look like. We're going to have a grid which is surrounded on all sides in this swamp. So those little stars represent the border of the swamp. And the stars that are in the middle of the screen, they're quicksand. So these quicksand can actually kill us as a player, but we can also trick the zombies because they always travel in straight lines. They make a beeline for wherever you are each turn. You can basically stand behind one of these quicksands and they will fall into the quicksand and die, and you'll be able to then escape from the swamp. So the zombies will move every time you press return to move. They will also move themselves, and we're going to put all that kind of game logic into our game. It's quite surprising that they've managed to do this in such few lines of code, but this is why it's not particularly graphical. So you can see that the H, we're the human, the Z's are the zombies, and the stars that are in the middle of the screen are the quicksand. So that's the controls. That's how we win the game. If you like this and you want me to do more kinds of videos, I don't know if people like coding videos on a live stream, let me know in the comments. And also let me know what your first computer was. I'm really keen to know, you know, is it all Commodore 64s, or is a lot of people who had other types of computer in there? So let me know in the comments what your first computer was. If you've not subscribed to the channel, also consider doing that. And I do go live every single Sunday at 7 o'clock. British summertime or GMT, depending on what time of year we're in. So yeah, if it's not daylight savings, then we'll be in GMT. So yeah, every Sunday check out and you can have a chat as well. Okay, so let's code. Let's get straight over to it, shall we? So let me bring up Visual Studio Code, and I'm going to talk you through the code that we have. So let me go over to Zombies Basic, and I will also just get my notes up on the screen. So yes, let me just grab this book. So like I said, we're going to go through a couple of different things on this book. So there's this hint section which will kind of explain about how you play the game, and then there's these line notes. So I've got these line notes kind of typed up here, and we can have a look at the basic code side by side with these line notes. Just have a quick look through, and then we'll start to do some actual coding. And I also want to show you what this game actually looks like to play for real. So I've actually got on this browser over here, I managed to find online the exact game that was typed by somebody, and it's in an emulator. So you can go down to Zombies, we can hit return, and it says there we go. So you've been abandoned at a lost Amazonian ranch of the Count Maru. Is that like what's the name of that famous island where all the weird creatures are? The island of somebody Moreau, is it? So this is probably just a variant of that, I guess, a rip-off of that. So the mad big game hunter, Count Maru, as luck would have it, the only game that he really enjoys is hunting is humans. So he sets you free on the ranch, and within a half day's head start sends 4 slave zombies out to track you down. Your goal is simply to stay alive. So we press the space bar for the next page. The ranch is surrounded on all sides by an impenetrable swamp, so there's no way of escaping from here. Pools of quicksand abound as well. So your only chance to survive is to lure the zombies, the Zeds, into the quicksand while avoiding it yourself before they catch you. Your position on the map is shown by a H, which we've just seen already. So with each turn you can move by pressing one of the keys numbered from 1 to 9. The arrow keys on the grid show the direction in which the player will move. If you press 5 you will stay still and kind of not do anything that turn. It takes very careful planning to outmaneuver the zombies. It's also completely random where you are and where they are and where the quicksands are. So let's press space, and there you go, that's the controls again. So it's kind of like that grid. So I just need to make a mental map of those as soon as the keys are all laid out linearly rather than in that kind of nice grid arrangement that we're going to do for our code. So the zombies always come towards you by the most direct route possible. They're not aware, for example, that quicksand is dangerous. Now this is really cool. Within 49 lines of code, they've got a bit of AI. They've got a bit of a machine. It's not learning so much as machine intelligence, because how do they know where to go to? They're making a beeline to you wherever you are. So it's quite clever that they managed to do that in such a few lines of code. Okay, here we go. We also have sound on this one as well. We have a few beeps and blops. Right, so there I am right behind a piece of quicksand. So what I'm going to do, I'm going to press 1 to kind of go diagonally up. And then I'm going to press 3 to go diagonally up again. And that zombie that's beneath me is now coming towards me. So if I press 5, he should go into that quicksand. He's died. The other two. Now this is going to get a bit tricky because one's higher, another's higher, and one's on the same level. So if I go down, say 9, and then maybe 9 again, and try and hide behind. I might have messed this up. Let's try. What would there be? 1, 2, 3, 4. Nope. No, I'm dead. I'm gonna die now. So if I just press up, I'll go into a zombie. So you are caught. That's the the end of it, and that's the game just quits at that point. So if you wanted to play the game again, you'd have to type in run, and then it would just start all over again. You can see we're completely randomly generated each time. It's interesting they don't use the full screen, they just use that small section. You can also see the aspect ratio of this is unusual, but this is, they had like 40 characters by 20 characters or something on these screens. It was not, the pixels weren't square essentially. So that's how you play the game. So if you want to check that out as well, just go to bbcmicro.co.uk and you'll find a games archive there. And this is from the Rainbow Book of Basic Games, Part 1, 1984. There you go. You can click on that. You can find out more about it. You can even download the code if you have a BBC emulator, but you can just play the games directly in your browser. So yes, this is pretty neat, isn't it? So that's what we're going to go for. What else do I need to talk about there? So the screen grid, which we've just seen as well, we could potentially have different sizes of grid because we could change that just by having a variable for how wide and how tall is the grid. And the zombies are really just positions in that array, in that grid. So really they're just coordinates. We've just got an array of zombie coordinates. That's really all that the zombies are. They don't have any other kind of attribute in our game, so they're very, very simple to model. And our position in the grid is also just an X and Y coordinate. And then the main game loop itself simply just says, are we in quicksand? If we are, we're dead. Is a zombie in the quicksand? If so, it's dead, and it just gets moved off screen to 0, 0. If a zombie has caught us, then we die. And if we killed all the zombies, if the array of zombies is all in that 0, 0 coordinate, then we've won the game or we've escaped. So that's really how the game loop will work. It'll just check for those conditions. Right, let's go back to Visual Studio Code. And let's start looking through. I'll bring up the zombie basic code. I think it's mostly typed out correctly. So let me get that there. And then I'll also try and get these code hints side by side. Oh, so they do have comments in. I did say before that they didn't have comments. They have these rem. These are reminders. And essentially it's like a comment. So rem zombies is just like a statement at the top of your code to say this is the zombies program, and then this go subroutine. So if I go to this book and I go to the very beginning, they've got a library of subroutines, and depending on which line we go there, so you can see that go sub, and it's like 1100. That will basically say mode 5, which is like a graphics mode of the BBC. VDU 19 probably clears the screen, I'm guessing, and then this width 20, D32. Not sure too much what they do, but they're just setting some variables up. I guess it's just like the variable widths and dimensions of that grid that we're going to draw out. So that's what that go sub does. That'd be better as being a function in Python, so we'll definitely create a function for each of those where we obviously go sub. Print does what you'd expect. That's very similar to MicroPython's print. And then let. If you've ever used JavaScript, you'll understand what let is. It's a way of defining a variable and then assigning it a value. So let t equal 2 is essentially saying the variable t will be an integer 2. We don't have to say it's an integer. It can infer that from the fact that there's just a single letter, a single value, whole number. And the other thing that's interesting is they've got these colons here, and that means you could write these on separate lines of code, but instead they put it all into one line of code. Again, they've got some more Go subroutines. We can jump over that for now because we can. It'll just kind of stop the flow of what we're trying to do here. But we can actually do that in Python if we wanted to. In MicroPython, using the semicolon, you can put more than one statement on a single line. It's just considered to be bad form to do that because you can't really read the code top to bottom, which is kind of how we really read code if we're skimming through and trying to find a problem. If it's all in one line, it might be like the third statement on that line, and you might miss it. So it's considered to be bad form. But the reason they did this in magazines particularly is just for brevity. For conciseness, it means you can print things on less lines. So that's what those little colons there mean. I put a space in here just to be able to align this to these like lines 100 to 130, sets the area of text and prints the title on the screen. So that's what that 4 lines there does. Now the other thing that's worth noting on here is these all end in 0, these numbers. So why don't they just have like line 1, line 2? Why do they have a 0 at the end? So does anybody know the answer to that? If not, I shall tell you. So often when you're writing these programs, if you wanted to think, you write your code and you think, I want to insert a line above that one there. If you'd had your code with whole numbers rather than these numbers with 0 on the end, it's quite hard to insert that new line. But what you could essentially do, if you wanted to put like an extra line on here, you could do, 101, and then you could just do like hello, something like that, or in capitals if we're sticking to the era. And yes, this would essentially allow you to insert extra lines in there. Once you've done that, you could then renumber. There's usually like a renumbering command, and it would go through and it would update all the numbers again with numbers with a 0 at the end. And it would also update any references to that as well. So it's quite clever. So everybody's guessing this because I think all these people probably program in BASIC. I'll just bring that on screen actually. So I think, let's see, that was yet another one who guessed that one first. And Bob as well. He said, allows one to insert a line between 2 lines. So yeah, once you do that renumber, it would update any references to previous lines as well, which is quite clever that it could do that. But back in the day, we didn't have IDEs. We had a very, very basic programming interface. Okay, so that's how we will do the first block. So that's setting up there. The next thing, 140 to 160. I mean, you could just look at these as like line 14 to line 16, I guess. Print area of the range within which you and the zombies can move. That's very odd English. So these lines here, print and then another print. So if you do a blank print, it just goes down a line, a bit like a printer, I guess. And then print will to print out a whole bunch of stars to start the grid. And then we've got little loops. So for I equals 1 to 13, that's almost like Python. So you can see there that it's going to basically print out a star, a lot of spaces, and another star. So that's going to form our grid. And then next I is incrementing the value of I. So essentially what that does is just says if I is 1, it does this, increments I is 2, and it'll go around until, just like a regular for loop, we've hit that main value there, 13, and then it prints the bottom of the grid area. So that's nice and simple. We can convert that into Python very simply. So then from 170 to 210, the starting positions of the zombies, which are randomly chosen, are shown. Again, this language is like from the 1980s as well. It's a bit back to front. So we're going to basically set some random values for our zombies and for the quicksand as well. So there you go. The next bit, 220 to 240, randomly choose quicksand traps and place them on the screen. They're just, again, positions in an array. and then your position will be placed on the screen as well at 250. So that's just a nice simple one. So let's scroll up to 250. So there we go. So they've crammed in 1, 2, 3, 4, 5, 6. Is that 6 lines of code, 7 lines of code, 8 lines of code into one little block of code there. And again, they've got some Go subs that do various different things. We can skip over that. Okay, then the position on the screen, so we've done that one, and then your position, your choice of move is registered. So this is going to read in from the keyboard a character. So we can emulate that using the import command on MicroPython. It's been nice and simple to do. And once we've done that, we can act upon whatever key we press or whatever direction we've done. The game loop can then update the new position, report if we hit the quicksand, straight into the swamp, or we're caught by zombies, or we've won. So lines 290 to 370 will basically update that game loop. So yeah, there's a lot of lets in here, lots of variables being set, lots of for loops and so on. So we're going to unpack this. So I'm just going to move that basic program to this side over here. And what I'm going to do, what I've started to do, just to make the show a little bit quicker, because it'll take a bit of time to type all this out, is I've created a skeleton based on those blocks of code that we've just looked at there. So line 100 to 130 sets up the area of the screen. So this is going to be the set area of the screen, print title. So this initialize screen function with print zombies and then print a new line that will basically represent that. And then these other ones, I've just put the word pass with a function name. So let's have a look there. Print the area within the ranch, which you and the zombies can. So I just got something in the way of the screen there. But which you can move. So that is essentially that line there. And we're going to fill this out in a second. We're just going to type the code in ourselves. So you can see what I've done there. For each of these blocks of code, I've created a function in Python. I've just put pass for now, which just does nothing. And I've also put some parameters that we can pass just to make these a bit more useful. So you can see the get key press will be registering the choice of our whichever move command we say, and then most of the game logic will be in the last block in this main function. So let's go up to the top and start writing some code. So I'm just going to get up on my other screen over here some sample code that I've started to write. Okay, so the first things I've done, I've just imported random because we've got a lot of random number generation to start at the start of the game to guess where the zombies are going to be and where we are and where the quicksand are going to be. So I definitely need to use random. And I've also included time just because we might want to put a little delay whenever we print something out to the screen. The next thing I've done is I've created two variables, one for grid width and grid height. So we can change this. We could have a much larger grid or a smaller grid depending on whether to make the game easy or hard or longer to play or not. And then we've also got two other variables. So how many zombies do we want? So the original game had 4 zombies hard coded, and the width and the height were also hard coded. We've got this quicksand count as well. So how many quicksands do we want to have in the game? That might make it easier because we can hide behind them. We might also get trapped randomly. So depends on how we want to play that. We can make it easier or harder. Right, so I've already filled out the initialize the screen section of the code. So let's do the get random coordinate piece. Right, so this is going to be a very simple line here. So let's just remove pass and let's say return. And this is going to be random randint 1 and then limit. So limit is being passed in. So what's the highest number we want to get a random number for? And we're basically just saying choose any random integer between the value of 1 and the upper limit, and then just return that back. So get random number will simply just return that random number within the range. That's nice and simple to do. Next is creating this empty grid. Right, so we'll probably want some kind of array to be able to draw this in. So let's just do a nice empty list. And I love how Visual Studio's trying to guess what the code is going to be for this, and it's not wrong. So we can say for underscore in range height, Now underscore, if you've not used that before in MicroPython, sometimes you want to know what the value within the loop is. Sometimes you don't care, you just want to go around the loop a number of times. So if you don't care what the value is, you can just do an underscore and it doesn't have to store a value, it'll just go around the loop. So we're saying then row equals an empty array, an empty list, and then for the range of the width, so however wide our array is, our grid is, then we can basically just put an empty character in there. And we want to append this new row that we created to our grid. So grid.append will just create that as a new line in our grid. So we just need to do that, and then once we've done that, we can just return that grid back to whichever function's calling it. So that's nice and simple to do. We can also have along this side here, if we want to compare how they did it in the original code and what we've come up with. So let's just find that starting position of zombies. They said that was, let's see, 170 to 210. So let's go to 170 to 210. So they've got two arrays, Q and Z, and we have two arrays, and they've got 8 by 2, which is, I think this is where they're just starting out with the number of zombies is 4, and they've got a second element to the array, which I think is where the positions are going to be, and the Q I think is quicksand as a guess. So we need to create something to hold that later on in the main game. We can actually move that to the main game loop instead, but that's what they've done there. And then they will print the Z on the screen when we draw out the zombies where they are. So that's just going to create our empty grid. We want to then have a draw function, right? So let's go down and do our draw function next. So this has got a bit more meat to it. So the first thing we want to do is we want to create that empty grid. So we've got the function up there already, so we can just say grid equals create our empty grid. We can provide the width and the height because we've defined them above as constants. And this is one of the new things that we do in MicroPython as compared to basic. We can use case to represent different things. So uppercase characters in Python and MicroPython usually define this as being a constant, whereas other variables such as the grid can be in lowercase. So, and we also use snake case rather than camel case, which is popular in like JavaScript. And snake case just means you have these underscores to separate words, whereas camel case would have the words squished together, and the only way you can see the different words is by the first letter of the word will be capitalized. So that's just a variation on house style. Right, so the next thing we want to do is place our quicksand in the grid. So we want to say for X and Y in quicksand, the grid Y minus 1 and X minus 1, so basically at the very start of our grid, we want to draw a star. So that's going to draw out the quicksand within that grid. That's going to draw the outline, I guess, isn't it? Let's just have a... Oh no, so we're going to pass in, quicksand, which will have the locations of these quicksands in. So wherever they are, X and Y within that are being passed in, we will draw them on the screen in the grid. So there we go. So next we want to place our zombies. So let's place our zombies on the grid. There we go. So for X and Y in zombies, zombies is going to be passed in as a parameter as well. And if X is not 0 and Y is not 0, that's when they're in the sort of, they've been killed and they're in limbo, they're in zombie heaven. So if they're at 0, 0, if they're not in 0, 0, they must be on the main board, and therefore we can actually draw a Z wherever they appear. So the grid coordinates X and Y minus 1, we can just draw them on screen. So that's going to place the zombies on the grid. Next up, we want to place the human on the grid. So that's just one of us. So we can pass in the human coordinates for this. Human X and human Y will become equal to human. Human has got 2 variables in it, so that will work fine there. And then we can simply just say grid human minus Y minus 1 and human X minus 1 equals H. So that'll just draw that nicely on the screen. Right, so now we need to draw the grid and its borders. So we want to print, this is a nice piece of Python, I think. So let me just show you this. So we're going to print a star, and then this star is separate from the star that's inside the speech string. And this means rather than just drawing 1, draw it multiplied by a number. So the number is the grid width plus 2, because we want to have a little bit extra because we've got some columns going down either side. So that's a nice little hack, rather than having to count how many stars you have like they have there. And how many is that? Is it 18 or something, if I remember when I counted that? We don't need to do that. We can have it dynamically draw based on the width of the grid that we've provided as a constant. Okay, next up then we want to, let's see, I've got a little for loop. So for rowing grid, and then we want to place this star, plus we want to join that together. So this join is like a string routine, and it's going to join whatever we've got in the row plus the other star. So it's going to just draw them with a blank bit in between, essentially. Okay, that's that, and then we then want to print the underneath piece, which is similar to that one there. So just do a whole bunch of stars depending on the width of the grid. That's it. That's how we would draw our grid. Next up, we want to have a delay. So this is simply just going to do a time sleep for how many seconds we pass in. It's a little bit redundant that we could just have sleep and seconds in our code. If I was probably going to rewrite this, I probably wouldn't have that as a function. I would just call the sleep function within the code. It's a little bit over-engineered to do it that way. But there we go. Right, the next bit, which is getting our key presses. So let's have a look what that looked like in this other block of code. So this was 260 to 280. Let's have a look what they had there. 260 to 280. So let's have a see. So they've got a whole bunch of these Go subs. I guess they're going to do the keyboard reading routines. So we can put that into our code here, no problem. So we simply want to say what direction do we want to go in. So direction is going to equal input and then enter the directions, and we want it a little bit different than that. So we want it to be W equals up, X equals, let's do capital equals down, S equals stay still, that's in the middle, A equals left, and D equals right, Q equals, oops, let me just scroll that across there, which is left and up, so up left, and we've got E is upright, Z equals down left, and finally C equals down right. Okay. So this input command, if you've not used this before in Python or MicroPython, this will essentially just ask the user, it'll print whatever you put in there on the screen, and then it will accept whatever you press. So it receives it as a string, essentially. So direction will be a string, hopefully a single character of the direction we want people to travel in. Okay, so next up we want to say some if statements. So we will say if direction, and let's do equals W, then essentially we're going up. So let's do that. Else if direction equals X, then we want to go down, like so. If the direction is S, we want to stay still, so we don't do anything. Let's just have that little comment there. It's a little bit boring, this piece. Then A equals left, so that's correct. Let's do that. Oops. So I want that comment to be in there just so we can see. D equals right. There we go. It's helping the autocomplete help me out. I'm just checking that it's guessing it correctly. So this should be up left. There we go. And then this is E, which is up right. Then we've got Z, which is down left. Just typing that comment there, down left. And then C is down right. There we go. That's it. And then we'll have a final else. if they've not typed in any of those characters, it must mean that they've typed in something that's not a valid character. So let's just say input invalid, please try again. There we go. And then we can return the get key press. Oops. So let's just return that, and that basically just does keep calling, try again if the input is invalid. There we go. Right, then we're going to get on to the main loop of the game. So we started out here, we're initializing the screen that's going to print the zombies. Then we have 3 variables, so human, zombies and quicksand. So these are all, well, the human is just a symbol, 2 coordinates. So human equals get random coordinate with the grid widths. So that's going to give us a random coordinate between 1 and whatever the grid width is. So if we had a grid width of, was it 20? Then it'll be 1 to 20. And then we're going to do the same again for the sort of y coordinate. So I'll get another random one between the grid height, 1 and the grid height. And then for the zombies, we've got an array of these. So we want to do this 4 times, or however many times we've got in our zombie count. So for whatever value in the range of 1 to zombie count, create 4 zombie coordinates randomly. And then the quicksand is the same kind of thing, but however the quicksand count is. We could just have 1 count if we wanted the number of zombies and quicksand to be the same, but I wanted to have them both separately, just so we could tweak it and have a bit more fun in our game. Right, and then we've got draw the grid. So we draw the grid, we pass in the humans, the zombies and the quicksands as parameters. It'll then update the screen. And then we've got this key equals get key pressed. So let me see what we need to do to build out this code, because I think I'm going to get rid of that. Let me see. No, it's going to be direction. So direction equals get key pressed. And that should be the name of that function that we've got up there, which is get key press. There we go. And we want to set our human x and y coordinates. So let's do that. Let's just set that under here. So human underscore x will become equal to plus equals. So whatever the current direction is, just add a value to that. And similar with the human y, we're going to plus equals the direction. Why is it not happy with ours? Because I've done equals as well. There we go. So this is the same as typing out human x equals human x plus direction. So that's all that's doing there. So we probably just need to update a little bit of code. So that initialize human. Let's just have a little block of code down here, because it's saying what is that red underline is telling me that we've missed a step out here. So let's just do that. So human x equals get random coordinates, and that's the grid width -2, because we don't need the extra columns on the end. They're kind of not a valid space. Do the same with the grid height, and then the human equals the human x and human y. So that is going to be a little array of those 2 coordinates, x and y. Right, so that means that this now is valid down here, which is good. So what we want to do next is we want to check if the human has escaped. So let's type that in. There we go. So let's just do check if the humans have escaped, and we can just say if zombies equals, and 2 equals means we're doing a comparison between 2 things. If we did 1, it would be an assigning of a value. So zombies equals is this the same as? So let's have in there 0 0. If the human has escaped, essentially all the zombies are in zombie heaven, which is at position 0 0. So for underscore in range, and then with zombie count, whatever that is, zombie count, all the zombies have been caught, and we can say, congratulations, you've escaped. Something to that effect. You've escaped all the zombies, congratulations, there we go. And we can break out. So break will break out of this while true loop. It'll end the game. So that's the first condition that we've tested for. We can then see if the human is... let's just update that. So is the human out of bounds? And this is just another simple test to see if the X and the Y are within the swamp, and if we try and go outside of that, it'll have a problem. So let's just move that so we can see this line here. So if human X is in one grid width, or human Y is in one grid height, in basically just checks all these different things. So if human X was, for example, 3, is 3 in 1, or is it in whatever the width is, 20? So we're checking for these extremes here. 3 isn't within those two things, so that would be false, or the human Y is in 1 and grid height. So it's just checking to see is our position in the very left or very right position, or very top or very bottom position of our grid, whatever our grid height and width happens to be. Just want to see why that's unhappy up there. That's because... did I just need to get that off there and then add it to the end there? Sorry, bit of a typo there. Okay, so if we are within the grid, we can say you're in the swamp, continue, so it'll carry on checking to see if there's anything else. So let's do another test. So that's the human has escaped. That's the human is in the swamp, and if the human is in the quicksand is next. So let's just do a little comment for that. Is in the quicksand. Okay, so this is just another check. If human X and human Y is in the quick, so let me just find that quicksand, which is just our little array of positions. If it is, then we can just print out you are in the quicksand. Break, because you've died, you've gone to a human heaven because you've stepped into the quicksand and you've been swallowed up by that. Now the next one is, let's see if we've been caught by a zombie. Let's do that. Why do I keep doing that? There we go. So this one is if the human position, the X and the Y, is within the zombie array. So if we're in the same position that the zombie is in, then we are dead. So we've been caught by a zombie. We can break out there. And then if not, we can then update the position and redraw the where we are on the screen. So let's just do human equals human X and human Y. We can then draw the grid. And we just need to pass in the updated variables for drawing the grid. And then we can have just a bit of a delay for half a second. And then we can move the zombies towards the human. So let's do this bit. So let's do a for loop for I in, sorry, I comma, because we want to pass in a couple of things there. So zombie X and zombie Y. And then we're going to enumerate them, which basically just means we just want to provide like a 1, 2, 3, 4 and a number for each of these. And let me just, I think it's trying to guess what the code is there, and that's not what we wanted it to do. So if zombie X equals 0, then we can continue. We can skip any inactive zombies. If the zombie is, let's do the call at the end of there. The zombie is in zombie hell. We know both, if any of the positions, the X or the Y, are in 0, that means it's in limbo. So we can just look at one of the values just for speed. So that means it's we don't need to calculate its position and move it on because it's already there. The next one, then we can say move the zombie closer to the human. So let's do that. This is quite clever because this is where it's kind of magical, because it looks like they are going towards you. So if the human X is not equal to the zombie X position, then the zombie x plus equals the human x minus the zombie x, and then this ABS here, this is going to we're going to divide it by let me just pull that up and show you what that is there. I want a better explanation of ABS. I've just not got it to hand, so let's go Python ABS. Let's have a see what that is. So returns the absolute value of a number. So it's essentially just turning a floating point number into an integer, I guess. So we can do that in Python by doing the double slash. So this slash slash, if you divide a number by another number, normally you get a floating point number. So if you divided like 3 by 4, you get a floating point number. If you do slash slash, you'll get the nearest whole number. So absolute number will do the same kind of thing. So human x minus zombie x is just going to bring us that bit closer. And we need to do the same thing with the y axis as well. Just get rid of that. So if human y is not equal to zombie y, then zombie y plus equals human y minus zombie y, and then divide by the absolute position of human y minus zombie y. So that will have the effect of making the zombie walk towards us, which is really cool. So we need to see if the zombie has fallen into the quicksand. So let's just do that. It's just a quick comparison between the zombie's position and the any of the possible positions of the quicksand. So let's just do that. So if the zombie's x and y is in quicksand, which is just an array of positions, then we can say zombies I, and then let's do the array there. So we're going to put him into the zombie heaven, zombie limbo, and then we can print a zombie got stuck in the, or falls into the quicksand, something like that. We can continue in our loop, and let's just check then if the zombie has caught we want to see if the zombie has caught the human. So check if zombie catches the human. And this is another comparison. So if zombie x and zombie y equals the human, so if we occupy the same space in the grid, then the zombie has caught us, we break because we've died, and that's the end of the game for us. Right, we then just need to update the positions and draw the grid at the end of this loop. So let's do that. We can get rid of that one. I think we've done that one before. So let's check. That. So let's update the zombie's position, redraw the grid. So zombies I equals zombie x and zombie y, and then we can just do a draw grid. Sorry, that's, yeah, this is all within a for loop for I, which is just the position in the array that we're currently looking at. Then we're going to draw the grid, human, zombies and quicksand, and then we'll just do a little delay for half a second. And then that is it. So what we need to do next then is just have if name equals main, and then run main. So let's just back that off to the very beginning like so. And I think that's it. Right, I'm going to try and run this. Let's see what happens. We might have some issues. It might run really nicely. So this is called Zombies Part 1. Let's just try and run this here. And we've got an error there. So this is in the if on line 132. So let's just find that. There we go. You can also just check. If I just remove that, you can see there's like a little red indicator there. That means that this it knows that there's a problem in the code and it's highlighting it. So that now looks like everything's green, so it should run. There we go. Right, so if we just scroll up, we have ... zombies, and we've got a grid. So that's a zombie, that's some quicksand, here we are. So it's not looking great. I'm going to try and run across here and duck down here, but this is going to be in hot pursuit, and he can go diagonally as well, remember, so he's going to be right behind me. I think this is not going to end well for me. Interestingly, this zombie over here, keep your eye on this one. He's right to the left of a piece of quicksand, and he's in the same line as me. So if I move right, which is what I'm going to do, he's going to hit that. But this, he's going to go down, and he is going to come. I'm saying he. They're all he's in this in this universe. Right. So I'm going to hit the D key to go right. So let's do D. So you can see that one died. That one came close. This one's in hot pursuit. I'm going to keep doing D and see if I can outsmart him. And then when I get to here, I'm going to go C to go down. And if I go right, he will die. If I go down, he will follow me down and kill me. He could actually get me at this position. So let's see if we do D. Let's see if we can get him there. And then this is not going to end well, because if I go up now, he's going to be able to go diagonal to get me, and then the game's over. So let's just do that. W to go up. It looks like we might actually be one. Yeah, we're just one step ahead of him. So I don't know how we can easily outrun him. No, there we go. The zombie catches you, and we've died. And that's the game over. So we can now try this game on a Raspberry Pi Pico. So let's go over to Thonny. I've got the version of the game I typed out just to check the code before I did the live stream. So this is the same code that we've just seen typed out there. But I've got a Raspberry Pi Pico plugged in. I've just got it just here. And we're actually going to run this game on a microcontroller. And the reason I like this is because we've just dropped it down there and it's just decided to go off. Let's just unplug and plug that back in again. Let's just hit the stop. There we go. I'm also using the absolutely bleeding edge version of MicroPython 1.23, which has the USB device stuff. We're going to definitely do a show about that. USB is essentially now hit MicroPython, so we can do like make our own mice and keyboards and stuff like that potentially. So we'll have a look at that. There's not many tutorials out there about this yet, so I might be one of the first to do that. Right, so let's run this and let's see what happens. So we can expand out our terminal so that we can see what's going on a little easier. There we go. So zombies. So we're over here, so let's make a beeline for this top area over here. So I'm just going to hit, just put my cursor over there, W to sort of go up. So I'm pressing W and return. And let's see if we can hide amongst some of these. So something weird's happened there. Looks like I've actually wrapped around the top of the screen. I didn't know you could do that. So let's just go left then. Oh, I got caught, so I died. So we can play that again. Let's just do run one more time. There we go. Oh, grief! So there's a zombie right on me, right on my back already. So I'm just going to go diagonally down. So I'm going to hit C. Oops. C in the terminal. Let's go left. I like the way when they update you see all the zombies sort of move around there. It's just like a chase now. Let's see if I can get ahead of him and then duck down here. Oh. So what happened there? It looked like the Pico just rebooted there for whatever reason. So yeah, so each game is completely unique. There used to be a game called Rogue back in the day. I remember playing this on the PC, but I think it even predates PCs. It was like a mainframe game, and that was like a generative dungeon, and you could find like amulets and food, and there was all kinds of zombies and other creatures that would chase you around, and it's very similar how it drew out on the screen to this. So yeah, this is a really fun game. It doesn't take too long to type in, and if you want to grab a copy of this, I'll show you where this is. So if you go to Kevin McAleer /retrofun, you'll find all the code there, the original zombie basic there, as well as the zombies.py. The zombies _ part 1 is the one that we've just been typing out during this live stream. So you can grab this code, load it onto your own microcontroller. It should also work with the Arduino ESP32 if you load MicroPython on there as well. Cool, so let's get back to our keynotes and let's see what we've got left of the show. So if you want to get yourself some merch, you can get yourself one of these amazing Robot Maker hats and help support the show at the same time. So go over to kezrobots.com/merch to check out all the merchandise that's available. And if you want to join on Discord, we have a Discord server. Just go to kezrobots.com/discord to get a free sign-up link for that. Just ask you for your email address. And if you want to follow me on social media, I'm on all the social medias. So you can go to what's that on Threads? So I'm at Kevin McAleer at threads.net. I'm on TikTok at Kevin McAleer 6. I'm on Instagram at Kevin McAleer. On X at KevSmack. On Mastodon Social at KevSmack, just Mastodon Social. And I'm also on Blue Sky at kevsmack.bsky.social as well. And you get all kinds of behind the scenes pictures and video clips. I was doing a couple today of Voltara, which is just behind me. That's now all up and running. You press the button and she animates and does all kinds of cool effects. And if you want to join me as well, you can do that a number of different ways. You can do a super chat, a super thanks if you're watching this live now. You can join the YouTube membership program, which really helps out to support the channel. You can also buy me a coffee as a one-off if you wanted to do that too. Go to kezrobots.com/coffee. All the links and instructions are on there on how to do that. So I wanted to give a big thanks to all the people who've supported the channel so far. So John bought me 3 coffees this week, which was very, very generous. Thank you for that, John. Somebody else who wanted to remain nameless has bought coffee as well. And so did Laurie and Tom. Thank you for that, guys. I really appreciate it. And members-wise, we've got Shemi, we've got Lee, we've got Alvaro, we have Marie, we have Jeff, we have Diane Corti, Marlene, Tom, and Steve Phillips as well. Marlene actually donated her BBC computer. I've got that in the main part of the house. That one still works. I can switch it on. I could load this code and run that on that original BBC from back in the day. The other thing I just wanted to note, where was that book that we had at the very beginning that I thought was quite funny? Must be this one here, Games BBC Computers Play. In here, there's actually a library card, and it says St Cuthbert's Secondary School, Bolton, and it's got a date in there. The last one was the 28th of February, 88. Now, an interesting fact, when I went to high school, my brother went to St Cuthbert's, and I went to Mount St Joseph's. These were 2 schools that were being combined into one, and St Cuthbert's doesn't exist anymore. It's now like a housing estate. That one got knocked down, and actually my brother went to St Augustine's, not St Cuthbert's. So I was going to let him off there. I was like, where's this come from? I probably had this because they were probably getting rid of loads of old books. Thank you, Matthew, for subscribing. Really appreciate that. So yeah, it wasn't... my brother went to St Augustine's, which got also knocked down and turned into a housing estate. St Cuthbert's. I think Jenny went to St Cuthbert's. They kind of split it, so like the first, second years went to that, and then they would go to the main Mount St Joseph's or Thornley. It's all history of Bolton here, but yeah, interesting that was like, if the library fine was still on that one from 1988, that's quite a long time ago. Anyway, we get distracted. So YouTube membership wise, we have Orlando, we have Paul, we have Johnny, we have Dale from Hybrid Robotics, we've got Warren, we have Stephen, we've got Jonathan, Oxrad39, John Paul Jolly, Alistair Ware, Cassie. How you doing, Cassie? Hope you're healing good. We've got Tinkering Rocks, we've got JDM, Johnny Bates, we have Hans from Cheerlights, and Michael, and of course we have Tom. So if you want to help support the channel, you can do that by going to kezrobots.com/credits and get your name in the credits too. Right, I think that is everything for this week's show. So it's at this point in the video where YouTube will recommend another video over here somewhere. So please click on that, watch that if you're watching this on replay, and I shall see you next time. And if you're watching this live with me now, let me just hit the stream marker button and let me see what people have been talking about. So yeah, wow, there's been quite a few comments going on here. Let me just scroll all the way to the top here. Oh good, people have been telling me what their first computers were. I was very interested to know what that was. Here we go. So we're nearly at the top now. It's funny how people are saying that they've got that same book. Right, there we go. So yeah, just at the beginning of the stream there, Marie was saying that she is having an earthquake where she is, so I hope everything's okay there. We're going over to San Francisco, not next week, the week after, for open source, so I wonder if we'll see any or feel any earthquakes while we're there. So here we go, here we go. So yeah, it should be great for printers. Let us know how it goes. Should be a great print. Oh, that's the bamboo you were talking about. This is going to be good, says Ford. I hope so. It was really fun to do the conversion. I remember looking at some of these games and thinking, God, that's horrendous. How did you ever understand what was going on behind the scenes? And I find Python a much simpler language to be able to model in your mind what's going on. It's a lot clearer what things are, but maybe it's just because I'm not as familiar with BASIC, because I'm not using that day to day. So what does ASCII stand for? That's the American Standard Code for Information Interchange. I know the whole 255 characters well. Remember, like was it character 13 was like delete or something? Yep, I remember those back in the day. I think that was one of my first Pascal programs, was to create the ASCII table. So Danny says, I remember that book well. Yeah, it's a really good book. So there are some really fun games in here, actually. I'll maybe have to look at some other ones for future ones. Some of them had like really interesting sort of graphics, and you thought, wow, I want to play like that game there. And then you look on the screen and it's just like a little pyramid of asterisks. There we go. But you've got to use your imagination. It's about learning the code rather than it is amazing graphics. But Danny says, love the idea of taking all basic problems and trying to make them with Python gaming libraries. Yeah, and it wasn't me who came up with this idea originally. Carrie Lawler did a YouTube video on it quite a while ago, like a week or two ago, and I remember thinking, like, that's so cool. That has been on my bucket list. I've just not got around to doing that, and I thought, why not give that a go? I think she didn't use functions in hers, and I was thinking, yeah, maybe we can use a few more, more modern techniques for doing this, because these didn't have functions in them, and it's like, how did you get by with this spaghetti code of just go subs and go tos? So yeah, another one says Unicorn regular font would be a good choice for the for Zoltar. Unicorn regular, I shall have to check that out. So if I spin this camera around here, I'll be able to give you a bit of a demo of what Zoltar looks like. If I go to, there we go. Excuse all the mess in the robot lab. So yeah, there's a font up here. I did this on the Cricut, and there's a little crystal ball that actually lights up, and she opens a mouth when you press the button that's just down there. So yeah, I'll do a show about that one separately, because there's just so much I want to show you about that. Jenny, go skiing. Yes, Jenny, that was one of I think my first game that I played. We had the ZX Spectrum Horizons tape, which was like a tape of loads of demo programs. There's one on there called Draw, and you could draw like vector graphics on there. I spent hours on that. I like the way that it would remember each thing you told it to draw, and then you could get it to refresh, and it would sort of refresh everything, draw it out one bit at a time. There we go. A equals B plus 1 divided by 5. There we go. I wish more languages used UK English. I failed a spelling test at school because I spelled colour the American colour. Yeah, it's weird. I think it's more of a French spelling of colour, is it? We have a very mixed language in the UK because of all the Vikings and the Normans and everybody that conquered us at various different times. Yeah, so you would use rem for comments. Thank you for that. I did cover that later on, but at the time I was thinking, did we have comments? They weren't very easy to sort of spot, I think. Hey, Cassie. So Bob said, how are you all? Library needs these types of books too. Maybe that's what I should go for, this kind of basic games types thing for MicroPython. I'll have a think about that. I've definitely got a book in me this year. I think I need to get started on that soon. Bob says, I remember those days. Type them into my Apple II. Yeah, awesome times. Cassie used an Amstrad CPC 464. Wow. Hey Nick, how is it going? Let's see. So Cassie's first computer was a ZX81. So I think I don't know if we had use of one. We didn't have our own ZX81, but I remember having a play on it, and it was black and white was the thing I remember. And as you typed each key, the screen would flicker. And it's because the processor was trying to either read from the keyboard or update the screen, and it couldn't do the same at the same time. It was very, very slow. And the ZX82 was actually the ZX Spectrum. They just called it Spectrum because it had colour. That was the main upgrade, as well as slightly faster, more RAM. I think the ZX81 had 1K of RAM, and the ZX Spectrum had 16K, as I remember. So yeah, the Timex Sinclair, which is the ZX Spectrum, that was Craig's first computer. It's interesting they call it Timex. Maybe they just had a different company kind of sponsor the name over there. So Marie had the Apple IIe. Jeff had the Timex Sinclair as his first one as well. Yeah, David's first computer was a Commodore 64, which is, they seem to be very, very popular. You can get your hands on them as well quite easily nowadays. They had really nice keyboards on those. The thing with the Sinclair ones, they had like the rubber keys or the just the membrane, and after a while that would really grate on you. They're very hard to type on. The BBC had a really nice keyboard. It was slow, but it was nice and clunky. So yeah, Jenny, yours was the BBC Master. Jenny's story with the BBC Master is she saw that there was a program you could like type list, couldn't you, to see like, or was it cat, to see like a catalogue of everything that was on a disc, and there was a game on there called Squash, and she was like, oh, I'll play Squash. It turns out that Squash was actually a compression program, and it would compress all the files that were on the disc, so you couldn't actually use them. So that was Jenny's first experience with playing with that. I remember that well. So it says, my first computer I used was an IBM 360. Wow, that's impressive. That's like a proper iron mainframe, isn't it? Island of Dr. Moreau. Thank you, Bob. Thank you. That was what I was trying to get at. So yeah, they clearly had done a pastiche of that. So Sparky in the house says ZX Spectrum 48K. Awesome. I think we had the ZX Spectrum 16K, and then we had like the pack that went on the back, and that gave you the extra RAM. And then I think later on we must have got an upgraded motherboard, because we swapped out the entire thing into the +1 case, which had like nicer keys and a reset button. I remember that being like the Raspberry Pi getting the on-off switch. The reset button was like a big deal for the Spectrum, because otherwise you have to like pull the power out and plug it back in. And everything was connected to the cassette tape as well. So the IBM 360 implemented a lot of what we use today. Absolutely, yeah. The really seminal piece of kit, that, wasn't it? Laura says, my first one I owned in graduate school was an IBM 286 clone. Couldn't afford one before that. I had a 286. I remember it really well. So my dad used to be a computer engineer back in the day. I think he worked for Thorn EMI and various companies before that. And I had essentially every PC, because they had spare parts, we could assemble enough to make a computer work. So I had a 286 and then a 386, and I think by the 486 I was in college, so I could buy my own motherboard, memory, graphics cards and all the rest of it. But yeah, the 286 didn't have any graphics cards capabilities. It just had was it Hercules graphics, like this green screen. So yeah, remember that back in the day. I remember when VGA came out, and that was a big deal. We were on EGA and CGA before that, sort of colour graphics array. So he says, Apple IIe was the first computer you owned. So the IBM 360 implemented multitasking and virtualization. So there's a really good book about IBM, I think it's the 360, by Fred Brooks, The Mythical Man Month. And I'm a project manager by trade, and this was about how the very early beginnings in the 1960s of like proper professional project management for this IBM 360 project, and they essentially thought if we put more people onto this project, we'll get a quicker result, because more people means more work means that there's like more achieved in that time, and they hadn't factored in things like communication. So what's the optimal size of a team? Is it 300 or is it 6, like in the agile kind of style? So yeah, there's an awful lot that was learned with the 360, not just in software, but also how to manage large projects. So yeah, it's a really good book, worth reading that. So he died, green, game over. Love it. So wow, IBM 360. I did have a mini computer for a while. We had was it an ICL? It had a PerQ was the name of it, PERQ, and it had a graphics screen. It was like a CRT, but it was portrait, not landscape. It was very unusual design. It had a mouse as well, and it was absolutely huge. So the hard drive in it was about 20 meg, but it was about the size of a dishwasher. It was massive. Martin says, I had a Commodore 64 Light Fantastic Pack, which came with a light gun. It came with some games like Batman and Pop Quiz. Awesome. So Ryan says, I was Commodore 64, but as odd as it sounds, I later owned a VIC-20 and a Speccy 48. I programmed the BBC micros in school. Yeah, I remember playing very briefly. We only had one BBC micro in our school. It was on a little trolley they had to wheel out. And because it was only one, you didn't really get much time on it. I do remember playing that game with the chicken, the fox, and the seed, and you had of the grain, and you had to get it across the river. And it was like a logic puzzle. I remember playing that one and figuring it out. As like people trying it and not being able to get there, I just sat there and figured it out and then played it, and it was fine. So yes, in college I had access to the chemistry course. Fortran ruled at the time via punch cards. Wow. Vin says, we used BBC at school, and I had a logo and a logo robot. Absolutely. So one of the things I've been looking at for BurgerBot is implementing like logo on that. It shouldn't be very difficult to do. So yeah. Yeah, so you can do like PD, that was pen down. I remember that one, Vince. That would make the pen go down on the robot, forward 100, so it would go forward 100 units of measurement. And it says, I encountered the logo a bit later on with the Amstrad PCW. And then people answering that, yes, it allows you to insert lines. That was when I was asking, why do they always end in 0, the line numbers? Bob says, it allows you to insert a line between two lines. So you both get it basic. So Donald says, I'm like, my first computer was a Sinclair 1000 with 1K of RAM. Used BASIC, but had to learn assembler in order to do real programming, and then went to Commodore 64. So I have on this desk actually this book. My brother, I think, used. He learned machine code for the ZX Spectrum, and I remember finding like lists of just ones and zeros, pages and pages of these, and he'd actually made his own compiler so he could write like assembly code, and then his compiler would compile it into machine code, and you could do some really clever like sound. He was really into like music. You could do some really clever sound, like having drums and multiple different instruments all through a speaker buzzer, which is just crazy that you could do all that. I remember listening to what he created there and just not understanding how those ones and zeros could possibly mean anything to anyone. But yeah, so that's that. Bob says, I think if Python had curly braces, I'd like it. No, we don't like any of that nonsense. It's just cruft. It just gets in the way. So Foxtronic says, just want to thank you for everything you do, brother. Oh, appreciate that. Thank you very much. And Donald says, huge congrats for huge. I think I inserted that. He said, I think it's because I read Hudic, and I thought that was huge. Kevin, congratulations for reaching 30,000 subscribers. I just noticed. No, I really appreciate that. Martin says, I think the Commodore 64, you could enter a number and it would, what was that, sort itself out for line numbering when you typed list. Cool. Yeah, I'm not played on that one, so I don't know. But I remember on the Spectrum, there was like a renumber thing. I think maybe after you'd inserted it, it would do it. But yeah. Off people, what was that, Alex? So, hello, how are you doing? So Danny says, I'm currently trying combinations of Raspberry Pi with camera modules to see which will work with libcamera. I'll be publishing what I find in a table. That's cool. I like the way Jeff does that as well, doesn't he? Jeff Geerling, he has like a table, like a mini database of things he's been working on. So yeah, I've been working on a little camera rig for 2 cameras. Let's see if I can get to this without messing everything up. I'll show you there. Can you see that little rig there? So I've got 2 cameras, and it's just sort of resting on top of that monitor at the moment. More about that later in the week, I guess. So Pete says, Home Assistant on Pi with an SSD. That's pretty cool. Yep, that'll work very nicely. Vince is working on setting up a Cricut template for the Picade artwork, so I can print and cut some designs to go on my Picade. See, I've got a Picade just there as well. They're working on a Picade Max, aren't they? Max Pro, whatever, massive version. So I remember when they were originally working on the Picade, this display here, this Galactic Unicorn, the idea for that was that would be above the Picade, so you could have all the artwork scrolling across. So it'll be interesting to see when the Picade Max comes out, whatever it's going to be called, because it's got 2 joysticks on, I believe, as an option. So that'd be an epic build. Combine that with a Raspberry Pi 5, pretty awesome. Lots of cool emulation. So Ford says, well, I just finished a project while I was watching this. That's awesome. A pan of brownies. Cool. Nice. So Jim says, is there a basic source code for this on GitHub? Excuse me. So yes, I just go back to here. You can grab that. Oops. Why did that disappear? Let me just jump back to there. There we go. So if you go to github.com/kevinmcaleer/retro_fun, you'll find at least my typings out of that. It doesn't have the Go subs in there in the book, but the book is available. If you just go to bbcmicro.co.uk, you can actually play the game in your browser just by clicking on that. There you go. You can go down to shall I play squash, Jenny? You can play zombies. There we go. Let's go back to the chat and see what everybody's talking about. And Jimmy's in Canada. Hey, how's it going? So there you go. So Jory says absolute makes the number positive. Thank you for that. So yeah, little trick there, isn't it? I remember ABS and CHI. Is it that? I think you can convert like ASCII characters to numbers as well. I used those. I'm pretty sure it was ABS for that. So yeah, looks like it's getting the sign of that difference. I see. So yeah, so -1 or +1 only. Cool. Reminds me of Doctor Who in the Daleks game in BASIC as well. Awesome. Yeah, there was loads of things like they take some really cool concept. That's what I love about this era of gaming. I mean, look at the artwork on that. The game looks nothing like that. The game is just like, you know, a H for human and a Z for a zombie. Yeah, love it. So it makes them go closer if they're left and right. Doesn't matter. They get close to the human. That's cool. It's just so clever how that one line of code makes the game look like it has like life, like they are tracking you down. Yeah. So thanks CS Study, appreciate that. So greetings from Belgium. I grew up making stuff on my Commodore 64 as a 10-year-old. Wow. So, and CS Study is in Ukraine. How's it going? So Danny says, does anybody remember the Input magazines? Wow, that does ring a bell. Yeah, we used to get Crash, I remember that one. And there was like a Sinclair user magazine, I think we used to get that as well. I'm sure the Crash one was like weekly. All Good Quake, very small one. Good, good. Good to hear. Yeah, character 13 is Carriage Return, there we go. I knew it was something to do with making things move around on the screen and you couldn't see it as a character. Because if you tried printing it, weird things would happen as well. So if you're trying to do like a table and you printed that to the screen, it would like go backwards one and mess up your alignment. It really is a Robot Lab without a mess. Exactly, there's so much mess in here. I mean, you're seeing this like really cleansed version. There's just so much garbage everywhere else. I'm making an absolute shed ton of these at the moment, so these will be for sale very shortly. We're intended to take a few of them with us to open source to sell. So I've been printing like an unholy number of these. So you'll be able to get those, I promise, very soon. So hope to assemble and code Smart Cubot Pro due to your videos. Cool. Smart Cubot Pro with my students in robocoding classes. That's cool. Definitely have to send some pictures, put it on the Discord server. Dexter says, my first one was a ZX Spectrum 48K. Yet another Timex US version. And Nick says he had a ZX Spectrum Plus. Awesome, that had the nicer keyboard, didn't it? Ford says, my first computer, as well as my earliest I can remember doing, was a Windows XP desktop. I forgot who made it, but parents kept it in the living room. Cool. And Min says, I went through Commodore 64, Amiga 600 to a PC, but I also had a ZX Spectrum and a C16. In school, I got to play with the BBC Micros. So, Ford's just giving away his age with that as well. So, yeah, probably born in, what, about 85 then or something, I guess, somewhere around there. And so he was spoiled by his parents. I always wanted to have an Atari ST 500 STE or an Amiga. That was I always wanted to have those, but I didn't get the chance to own one of those. And the trolleys, I remember those. Yeah, they had like a trolley for like, you had one for the TV and the VHS cassette, and the kids would like, whenever somebody put a cassette in and it was like terrible, some smart kid would always like, tracking, change the tracking, and you did this and it adjusted the head slightly and the picture would hopefully get a bit better. But there was like, piracy was rife in primary schools amongst teachers. Like I remember I went to like a Catholic school, and we always had around like Easter time Jesus of Nazareth playing on the TV, and like the sound was totally blown out, and it was like a 10th generation pirated copy as well. Terrible. So I remember we had a room especially for the TV called the AVA room, the audiovisual and something room. Yeah, they had xylophones in there as well, I remember, and that's where the BBC lived. So the engineer would come out and fix them, lift the lid, press the chips down and see that'll fix it. Ah, yes. Yeah, the chips would pop out the BBCs. I think they were designed to be like upgradable. But do you ever get spam bots in your comments for videos? We do occasionally, and that's why we have moderators. So I've got some keywords to help protect against that. Hey Mellow Labs, how's it going? Thank you for doing the live stream and chat the other week at Maker Central. Really enjoyed that, speaking to you. I didn't realise you could ask to get the badge to be an exhibit. What's it called? A creator, or not just an exhibitor? I should have checked on that one. So yet another one says had 4 binders of input. Wow, I've just got loads of Magpie magazines and Hackspace magazines. Great meeting you at Maker Central 24. Likewise, yeah, it was a good show, wasn't it? I really enjoyed going there. So Vin says we had a TV hidden in a Wendy house in the lower school, full size adult height, and used to watch BBC recordings in there. The magic pencil, I remember that pencil that it lit up at the end, didn't it, when it used to draw? And I was like, how are they doing this? How is this pencil floating? I didn't really understand green screens back then. So, but yeah, that's clearly what that was all about. Let's see, so just jump there we go. So Ford says, this morning I spotted a couple of porn bots in the comment section of Explaining Computers video. They pop up like bunnies. I mean, he's got over 1 million subscribers now, so he's going to draw all kinds of bots on there. I'm always worried that somebody's going to like hack the channel and just like some garbage cryptocurrency thing come on to the channel, and just I'll have to like speak to YouTube. So I've done all the things like you have to record all the details are like when your channel is set up and so on, just in case you ever need to request to get the channel back. But I always live in dread of that, because you put so much effort into this thing and then you're just beholden to security being what it is. So at this point I'll say thank you so much for joining me on this epic journey to space and zombie swamps in the Isle of Dr. Moreau, and yeah, I shall say thank you for watching, and I shall see you next time. Bye for now.